chapter 6, and we're going to start with 6.2. And today we're going to talk about standard normal distribution and the uniform distribution. As we've done probability distribution from chapter 5, you realize that to have a probability distribution, that all the values in the probability distribution had to be less than 1, and the sum had to be equal to 1. And that is very similar to what a normal standard distribution is called. Most of you have heard of this called as a bell curve. And when we describe a normal distribution, we're looking at a specific curve that looks something like this. And based on this, a standard normal distribution has a mean of 0 and a standard deviation equal to 1. So we have to remember that. So that's mean of 0 and a standard deviation of 1. And based on that, the area under the curve of a normal distribution, the area has to equal 1. And as you can tell, the ends of this normal distribution are open. They are not closed. There is not a specific set endpoint. Because at the ends, even though these values on the ends are not very likely probability-wise, there is still a possibility. So we can't make it a closed curve, but eventually it gets closer and closer to 0, but doesn't actually touch it. All right. So the three things that we have to focus on is the graph in the standard normal distribution is bell-shaped, as you can tell. The standard normal distribution has a mean of 0 and a standard deviation equal to 1. All right. So based on a standard normal distribution, we determine probability based on something called a z-score. A z-score is the number of standard deviation a particular value is from the mean. And to find the value of a z-score is equal to the value you're looking for minus the mean over standard deviation. And that's the sample formula. The other formula is z equals x minus mu over sigma, which is the population formula. So this is sample, and this is population. All right, so when we're looking at this, in order to find different probabilities, you have to use something called the z-score chart. The z-score chart is in that green fold-out. You have z-score positive, z-score negative, and it's also available in the back of your textbook. If you go to the very back of your textbook, the last on the back cover is the positive and negative z-scores. Now, so what we're going to do is we're going to take a look at how do you define probability based on a particular z-score. So we're going to look up a z-score on the chart. Now a z-score is a value usually less than 3 and greater than -3, but sometimes you see values larger or smaller than that. And it always has 2 decimal places. So a typical z-score, for example, let's look at a z-score of 1.72. Now, when you're trying to look up a probability on the z-score chart, you have to divide this into 2 parts. You have your first 2, so the first column you look for the first 2 values. You're looking for 1.7 as you go down the first column. And then the top row, you're looking for 0.02. So in the first column, we're looking for 1.7. The top row, we're looking for 0.02. So if you look at your z-score chart now, you should be able to locate the probability. So you're looking at the positive z-score chart. So you go down the first column to 1.7, and then you go over to the row, or go over to the go down over the 1.7 row down the 0.02 column, and you should see a probability of 0.9573. So the probability of a z-score of 1.72, and the probabilities are always less than that. So in this case, the 1.72 would fall over here on the right-hand side, and we're looking for the area to the left. Now the z-score chart will always give you the area to the left. So based on that, the area is 95.32% of the data, or 95.73% of the data will fall below a z-score of 1.72. So why don't you take a minute and why don't you find the z-score, pause the video, find the z-score of z equals a negative 1.31. So this is negative 1.3 down the first column and 0.01 across the top row. Find where those two intersect and come up with a probability. All right, if you looked up the negative z-score chart, you should have found a negative 1.31 should have given you a probability of 0.0951. So this gives us a probability of a negative 1.31 as 0.0951. All right, after this, so any questions on that, please comment down below and we can go over and redo them, or if you send me an email, we can cover additional questions at this point. Now, the main point we have to do next is we have to work backwards. We're going to be given a probability we need to find and come up with the z-score. So in this case, we have to use our chart and then we have to find the probability that's closest to. So what we're going to do is we're going to look up the probability of 0.8750. Okay, 8750. Now, if it's greater than 0.500, it's going to be on the positive chart. If it's less than 0.5000, it's going to be on the negative chart. Because on a normal distribution, half the data is going to be less than 0 and half the data is going to be greater than 0. That's why it's normally distributed. It's even. So let's look at 0.8750. It's going to be on the positive chart. And once we look at the positive chart, we want to find the value closest to 0.8750. So if you look at all the data values that are in the middle of the chart, you need to find the row and column that intersect at that closest data value. So in this case, 0.8750, I can find a 0.8749 at the intersection of 1.1 and 0.05. So that means this translates into a z-score of 1.15. So if you haven't figured that out yet, take again, look for this in the main data chart. Look for the 0.8750 in the main data chart and look for the row and column intersection at that data value, and that will give you the z-score that you're looking for. So that's working backwards. All right. So let's try a problem or two. So let's look at 6.2 on page 248. We have example 3. Excuse me. All right. So it says a bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. The population of z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So these tests meet requirements for a standard normal distribution. A randomly selected adult undergoes a bone density test. Find the probability that the result of reading is a reading less than 1.27. So we need to find, so when you're doing your work on this kind of problem, so it asks you for the probability of a density score less than 1.27. So when you're showing your work, you're going to draw in your distribution curve with your mean listed. In this case, we have a mean of 0. So we can say it's normally distributed, a mean of 0, standard deviation of 1, and we're looking for the probability of 1.27 and less than. So you would draw in a line at 1.27 and shade to the side that we're looking for. So in this case, we went less than 1.27. So now you're going to look at your z-score chart. Since 1.27 is positive, we need to find the probability less than. So if you look at your z-score chart in the back of the book or in your green foldout, you don't go down the first column to look for 1.2, and then go over that row until you find the 0.07 column, and we would find the probability less than 1.27 to be 0.8980. So that means the probability of getting a test score less than 1.27 is a 0.8980. Now, let's try another one. Let's say I need to find the bone density score that gives me the probability that the person getting that test score is less than 75%. So I need to find the z-score in which the area to the left is 0.7500. So I'm looking at a z-score that gives me a probability of 0.7500. So I'm looking again, since 0.75 is greater than 0.5, I look at the positive z-score chart, and looking at the data values in the middle, I'm looking for the closest one to 0.7500. And in this case, as I look through the middle data set, I find that there are two values that are somewhat close, but the closest one is 0.67. See if you can find that on the data set. Now the 0.67 is 0.0014 away, but why the 0.68 is 0.0017 away. So which makes the 0.67, this translates into a z-score of 0.67 as the score that I'm looking for, that 75% of the data values will fall below. All right. So that is finding z-scores and working backwards, taking a probability and finding the z-score. Now, another way we can do this is I want to find the values in which are one standard deviation away from the mean. So I need to find the probability that, let's say I want to find the probability that it falls within 1 and -1. Okay? So I'm not finding the complete tail, I'm finding the values in the middle. Now, in order to solve this one, we need to find the probability of getting 1 or less, and then subtracting this tail, which is the probability of getting a -1 or less. So first thing we need to find the probability of getting a z-score equals 1. So probability of z equals 1. Or, yeah, the z. And we find that that probability is looking on the z-score chart. So 1.00. I get a probability of 0.8413. Now, I look again at the probability of getting a z-score of -1, because we need to find the values between. So we're going to find the probability of 1 and subtract the probability of -1, and that gives us the value in the middle. So if we look at the probability of -1 is 0.1587. So then I would subtract 0.1587 from 0.8413, and I would get the probability of it falling between. So grab your calculator, subtract 0.8413 from 0.1587. And I would get the probability that z falls between -1 and 1 to be 0.6826. So anytime you're finding an area between, you always find the z-score of the far right one and subtract the z-score or the probability of the far left one. And once you find those probabilities, then you can find the probability in between. All right, so let's look at one more and that part, and then we will, I will let you continue on with your homework for the beginning chapter of 6.2. That is the material covered in 6.2. All right, so let's take a look at, let's say I want to find your example is example number 4 in your textbook. And we're going to try to find the z-score, or the probability that I get a z-score or a test score that falls between -2.5 and -1. So we're finding the far tail. Now, since both of these are negative, which one's the furthest one out? So in this case, we need to find the area between -1 and -2.5. And we're finding this small percentage. So in this case, the far right one would be -1, the far left one would be -2.5. So we need to find the probability of a z equal to -1 first, and then the probability of z equal -2.50, and find those probabilities and then subtract them. All right, so if you take a minute, the area to the left of -1 is 0.1587. And the probability of negative 2.5 is 0.0062. So you subtract them, and you would get the value of the probability between both of them as 0.1525. All right, good. Now, the last thing that needs to be discussed in this section is, what if I want a value greater than a particular value? I want to find the probability greater than. So I have my density curve, or my normal distribution curve, and I want to find the probability that my scores are going to be higher than 0.75. Now, if you remember, the area of the entire curve is equal to 1. So I need to find this area over here. This is what I'm looking for now. I need to find the probability that z-score is greater than 0.75. So in order to find that, since the chart only gives me the values less than that particular value, so to find this probability, I have to find 1 minus the z-score, probability of a z-score, less than 0.75, which is the data value in your chart. So let's look up z-score of 0.75 in your chart. So again, since 0.75 is positive, we look at the positive z-score chart and go down the column for 0.7, go down that row until you get to the 0.05 column, and I get 0.7734. So this value is 0.7734. So to find this value of greater than 0.75, I take 1 minus 0.7734, and I get a value of 0.2266. All right. Well, this concludes the section on 6.2. If you have any questions, please comment down below or email me about the information. And your homework assignment is on RenWeb for 6.2.